Okay, good afternoon, everybody. Let's start the session of the defense of the final work on the production engineering course of Alex Paranahyba de Abreu. In this examination board, I have two big friends, Rubén and Pedro, who I really admire, and I'm a big fan of both of you. You both are important and international researchers in operational research. Rubén Ruiz is professor in Universidad Polytechnic de Valencia in Spain, and Pedro Munari is professor in Federal University of São Carlos. In the first part, Alex will present his paper during 15 to 20 minutes, and then we pass the word to the colleagues to questions and comments. So Alex, feel free, good luck.
Thank you. I'll share my screen now. Just 1 minute. Can you see my screen already?
Yes.
Okay. Okay. So thank you, Helio, for the introduction. Good afternoon and good evening for everyone. And I'm pleased to be here presenting my undergrad final work, an efficiency and robustness analysis of warm start mathematical models for idle and waiting times optimization in the flow shop. For the committee board, Professor Ruiz from the Valencia Polytechnic University in English, and Professor Pedro Munari from Federal University of São Carlos. Please, this is such an honor. Please note that this paper is currently under peer review by the Computers and Industrial Engineering Journal. So the presentation outline starts with we have 8 sections. The first one is the contextualization and motivation of the work. The section 2, we describe the problem. The third section, we present the models. In section 4, we show the experimentation design. The section 5, we show some partial results and partial conclusions. Section 6, the improvement procedures implemented, and finally the final results and overall conclusions, and then the acknowledgements. So the baseline here is that you use a flow shop structure that basically is a set of machines and that jobs needs to be processed by them and are a set of jobs. So in the case of a set of jobs, we use a permutation flow shop structure that maintain the order of the jobs in each machine. So about the performance measure, we saw that the most considerable one is the make span, that basically is the completion time of the last job in the last machine, basically this bold line here. And for some practical application, other indicators are more suitable, such as machine idle time in blue and job waiting time in yellow. The front idle time, the front idle is the time between the start of the schedule here and the beginning of the first job operation here in each machine. The core idle time is the time that the machine waits between the jobs here within the system, and the core waiting time is the time that each job waits to be processed in the following machine. And the back idle time is the time between the completion time of the last job and the make span. So our core motivation is that there are no existing paper comparing exact models that address the jointly minimization of idle time and waiting time. So there is indeed jobs that address idle time minimization and and other works that address waiting time minimization, but not both together. Comparing models, exact models. So formally, our problem description definition is the first point that our objective function is the sum of total core and front idle and out idle time and core waiting times or waiting time minimization, and we do not included the back idle time because this time could be further used for a next schedule. So in blue and yellow is the times that we considered. We do not consider here the back idle time for the objective function. The third point is that we address the permutation flow shop structure. The fourth point is that processing times are known beforehand, so we applied deterministic optimization. And last one is all jobs are available for processing in the beginning. So we can schedule in the first position each job that we want. Every job is available. So to address this problem of to minimize total idle and waiting times, we implemented four mathematical models. The first one is a sequence-based with dichotomous constraints from main. The objective function is that showed that in the presentation. The main aspects of the model are the idle and waiting times are explicit variables, such in this constraint, for example, and we implemented a new variable y to address the jobs adjacency relationship to compute the idle time, the core idle time. And we also included a new constraint to compute the front idle time that was not included in the original one. So V is basically that value that 10 times the total processing time of jobs and is used in both models 1 and 2. Model 2 is also a sequence-based but adapted from Liao-Yu, from the Liao-Yu formulation. It used the same objective function, and the main aspects of this model is we included the surplus variable Q to combine mains dichotomous constraints and the inclusion of Q boundary constraints to ensure the feasibility. And also V assumes the same values for models 1 and 2. Model 3 is a position-based adapted from Wagner, and it used this objective function with the strategy of position-based also. And the main aspect of the model is the JML property, the job adjacency machine linkage property that address the relationship between jobs and among the machines. So basically we have three variables, X, I, and W. Model 4 is also a position-based, but adapted from Wilson. It used the same objective function as used in Model 3, and the main aspect of the model is the representation of the JML property with two sets of equalities instead of one set of equalities. And also we included the constraint for this constraint from Model 3 to compute the front idle time. So with these models, we will address the experimentation design. So implemented this model, 4 models, into 240 instances from Thailand benchmark of processing times of size N and M, this size of NMN. And the computational settings are those, and we highlight the computational time for each run in each instance was limited to 1 hour. The results of computational times and optimality gaps of each instance were evaluated through the performance profile method The performance profile method indicates how efficient when the models have better solutions, and how robust when have more integer solutions is a model. How efficient and robust is a model. So basically here we have the partial results from the comparing the 4 models that we implemented. We highlighted 4 points. First one, we can see a clear difference between the groups of position-based and sequence-based here. So position-based outperformed the sequence-based models. And among the position-based, we have that model 3 is more efficient because achieved more optimal solutions, one instance more. And model 4 is more robust because achieved less no solutions, more integer solution, even optimal or feasible. So basically, we have this partial result. So to decide which model between 3 and 4 is the best, basically, we did a visual analysis on those graphs, and we realized that the curve behavior of model 4 presented itself as superior. So for both computational times and optimality gaps. So we observed that the model 4 is the best one between the four initial models. So as we see, these models struggle to deliver optimal or even good solutions, and we know that heuristics provide fast, feasible, and approximate solutions. So our idea is to combine them. So we implemented 3 heuristics in the same test bed as we did for the 4 models to evaluate its individual performance. The heuristics were adapted to minimize the objective function IW that we name it for short, but is the total sum of core and front idle and core weighting. So the heuristic that we adopted and implemented is the NEH from Nawaz, Score, and Ham. The short processing time, SPT for short, and largest processing time, LPT for short. So those their results are that NEH, evaluating the average relative percentage deviation from the solution that they provided, NEH provide better solutions for this problem, and LPT provide the worst solution in average for this problem. So with those results, we included the solution of the objective function into the model as an upper bound to reduce the set of feasible solutions. So our idea is to at least improve to achieve a fast solution into the models, the new models. So our final results are also 4 points that we highlighted. We cannot see clearly the formation of clusters between the procedures. So no cluster of results between those procedures, but they are different. But for optimality gaps, we see similar results. Such similar results that we needed to do the x-axis in logarithm in base 50 to zoom in and see how different they are. But even doing that, we cannot see how different they are. They have similar results for optimality gaps. We can see also a performance inversion of the heuristics. We saw that NEH provided better solutions, but when included in the model, they provided, in terms of solutions, the same results, the same quantity of instances, the same number of instances, such as model 4 without the insertion, and LPT that provided the worst solution itself, with the model provided 2 instances more with optimal solutions. in terms, in absolute terms. So in performance profile evaluation, we can see that model 4 with the LPT heuristic have a superior curve behavior. And we can see also that model 4 with the NEH has an inferior curve behavior than model 4 itself. So model 4 presented a superior curve behavior than with the NEH heuristics for computational times. So our overall conclusions is that our main contributions, the main contributions of this work is the wide literature review that we did, addressing this idle and waiting time optimization. So we saw how pioneer this work is. The second point is the comparison of 4 models to this problem. So we saw that the position-based one outperformed the sequence-based, especially the model 4. And the implementation of the warm start strategy, of including the initial solution of heuristics, we really saw an improvement. So evaluating these results with the performance profile method, we saw that the model solutions were improved by inserting the heuristic solutions. And finally, I want to acknowledge those. I'm deeply grateful for Helio's immeasurable partnership in the development of this and other work that we are currently doing. The participation of the committee board, Dr. Ruiz and Dr. Munari, thank you very much. This is such an honor to present to you. And also my family and friends' patience and support in the most challenging and exciting moments, such as this one. The financial support of Brazilian National Council for Scientific and Technological Development with 2 scholarships. And also the journal's referees comments on an earlier version of this manuscript. And also Antonio technical support for this presentation. So thank you all. Thank you all for your attention.
Very good. Thank you very much, Alex. And indeed, we deep thank the colleagues Rubén and Pedro for accepting our invitation, and I'm sure you have good contributions here. So firstly, we invite Rubén to your questions and comments. So free, please.
Ok. Muito obrigado, Alex, pela sua apresentação.
Muito obrigado.
Este é um trabalho de alta qualidade. Excelente. Okay, so I change English. Otherwise,
okay.
I might sound a bit funny. So I'm a bit confused. You told me, Helio, this was undergraduate. Okay, so it is undergraduate. So okay, so I have to say this is, to me, for at least for Spanish standards, this is more like a master thesis type of paper. So this speaks clearly about its quality. I will never ask an undergraduate student in Spain to go this deep into a problem. So this is really high quality work. I really enjoy reading it. I know a little bit about flow charts, so for me it was easy to follow. I have also modeled in the past different models, so the choice for man models, it's a good one. So the 4 different models are very well chosen. I also like how you frame the problem. I never thought about minimizing at the same time waiting and idleness, because idleness somehow it's captured by makespan, but not entirely. So minimizing idleness only is probably correlated with minimizing makespan to some point, but if you add the waiting time of the jobs, then it's a different objective. And I think it's very interesting in practice. because waiting time for products, it means that the products are sitting somewhere at the factory, and you don't want lots of products to be sitting in a factory for a long time. So it's a very interesting objective. So I have just a few comments and a couple simple questions. And the comments are probably to help you eventually improve the work since it's being submitted. Okay, so first comment, probably referees already mentioned about it. When you use a solver, you have to make sure you use the latest available one. You are using Gurobi 811. I think it's about 2.5 years old. The latest Gurobi version was 9.1.2. It is from March this year. And since it's free for academic purposes, it's always a good idea to use the latest one available. Also, almost since you are using Julia and you can interface very easily with other solver, I would propose to compare with Cplex also. Gurobi, in my experience, is very good, but sometimes Cplex is better. So a common question by referees might be what is going on with another state-of-the-art solver. And there is still some old referees that don't know that Gurobi exists. So they will probably say, what is this? So, yeah. I would also like to see some statistical analysis in some of the tables also, especially when comparing models 3 and 4, because they're very close in performance. So sometimes, yeah, when results are so close, the question is, are the observed differences statistically significant or not? Yeah, and then one question, when you do the warm start, are you feeding just the objective function value that you get with a heuristic or the complete solution? From table 8, I think that you must be feeding a complete solution. Is that so?
From table 8?
Yeah, the question is, when you are warm starting the solver, are you feeding to the solver a complete solution? I mean, all the values of the variables, or just the objective function? I think it's the first, but I wanted confirmation.
We inserted the objective function. The objective function, just the objective function.
Okay, then a very, very easy way to improve is to feed a complete solution. Because the problem with feeding only an objective function value is that basically you're giving a bound to the objective, and you're asking the solver to first prove that that bound is feasible. So the solver spends a bit of time proving that feasibility and then continues solving. However, if you feed the complete solution, like the values of all the variables that give you that heuristic value, then you are giving a starting branch value for all the variables. And in my experience, that helps quite a bit. So as you can see, it's just comments, okay? I'm not saying that the work is bad, rather the contrary. This is a master level work. It's excellent. I'm just giving you pointers to see if you might be able to improve. If the referees give you the chance to revise, then you can probably add this or add this in another paper and so on. So excellent work, excellent presentation. The performance plots are really nice also. So yeah, for me, it's perfect. Use LaTeX next time. This looks like Word. But other than that, it's perfect. Thank you very much. And I feel honored to be here and to be invited by my friend Helio. So perfect way to start the weekend for me.
Fantastic. Thank you very much.
Thank you.
Any comments, Alex?
No, just to think. Thank you.
Okay. So now, Pedro, it's your turn. Please feel free.
Thank you very much. Thank you, Helio, again. Well, first of all, for inviting me, it's a big honor to be here. I really like the invitation, so thank you. And first of all, congratulations to you and Alex for the work. as Ruben said, well, this is way beyond what you should expect for the undergrad work, so congratulations, it's very good. Congratulations, Alex. Well, first of all, for writing in English. I mean, you've accepted a lot of challenges. I think, I'm not sure if Helio was very pushy on you, was very, a bad supervisor, or if it was just because you wanted to do the best, but congratulations. I think that you accept a lot of challenges. First of all, writing in English, it's a challenge for us, right? It's not, you don't see many, final works like this in English. At least in my university, we don't see any of that. And well, the presentation in English is also a challenge, so congratulations for this. For the comedy you chose, this is another challenge. International, researchers here, so it's important for you. And also for submitting your work for publication, this is another important thing. It's a good journal, right? It's a top quality journal, so congratulations for that. Anyway, and of course, congratulations for the quality of your document here. I really enjoyed reading it and see a lot of models on it and computation experiments. So I have a lot of good things to mention about it. Of course, this is not perfect yet, so I have a few comments about the text. First of all, this was a good comment by Ruben. I didn't notice when I was reading that you're actually using the upper bound only. Okay, and this is something that should be clear in the text. All the time, maybe because you're saying you use the warm start, and Cplex and Gurab, they have this MIP start, and MIP start for these codes is just when you provide a solution, an initial solution. And then for this reason, I thought you were providing the solution. And it's important to provide the solution. Why? Because they have a lot of heuristics, and sometimes they will use this solution you have with some local search or things like this. They just, erase part of the solution, try to improve other parts of the solution. And then maybe if you provide the solution as they start, it will help you with the computation experiments here, of the performance of your approach. So this is a good thing to do, right? Well, let's, okay. There's another thing here that you mentioned several times in your document here. It's something that usually we see. I think I've made this mistake in the past in my papers, but now I try to not do this. It's because sometimes when you propose a model or you are just testing a model, you just say, okay, model 1 is better than model 2 because it's faster, or the model found more solutions than the other model. And you have this. But in the end, the model just is a model, right? The model cannot find a solution by itself. It's Gurobi or Cplex that is finding the solution. So it's just a matter of rephrasing the sentences. We know, of course, what you're meaning. But to be really, precise, to be more, to be correct, we have to say, well, Cplex or Gurobi or the solver I'm using found more optimal solutions using model 1 than model 2. And this is important because sometimes if you change the solver, you can get different results, right? Sometimes model 3 will be the best and not model 4 anymore. And anyway, so you can get you can have some surprises there. So it's something that you should just have a look when you have phrases like this, sentences like this saying something about the model. It's actually the solver using the model, right? Let me see. I have a small things that I found. I'll just send you the PDF later so you can check. What else I found here? Let me see. Okay, this one is a small thing. Right. There's something in your document. For example, if you go to page 9, where you define the problem. I'm not sure if this is something usual in this flowshop literature. Maybe because I do not know this very deeply, I don't recognize this. But when you're talking about a job, why don't you use just J instead of JJ? Or when you're talking about a machine, why not using just K, instead of MK? Is there a reason for that?
Yes, kind of a reason, because for example, model 1 and 2, we can like have a job. We assume the sequence of the job. So we implemented the J as an arrow. So the index of J, I, or something like that are to address this relationship that is the sequence.
I see. Okay, but I mean, when you talk about sorry, when you talk about in the text, when you are writing, for example, why can't you use just job I or job J? That's in the model. Okay, in the model you use I and J, but in the text, for example, the paragraph just before the figure, you could use just J or K, right? I think this would be easier to read if you do that. That's just my suggestion. Maybe for the paper now, right?
Okay, thank you.
And there's something in the next page, page 10, actually, yeah, page 10. When you say in the second paragraph, right? In this paper, we consider the third definition as part of our objective function because it's assumed that the final gap could be used to restart the schedule. I couldn't understand the meaning of this sentence. Can you explain that to me? What do you mean? First of all, what do you mean by the restart? By restarting the schedule? And why this choice?
Okay, so basically, we decided to do that because we are considering, basically, we can say that we are starting the production line, for example. So the first sequence of jobs for five jobs, for example, we did the schedule and implemented, but the line will keep working, so we can use like do another scheduling optimization and use that time.
Oh, I see. Okay, maybe it's, yeah, maybe I'm not sure if this is if someone from this area, could understand this, but maybe someone that is not, in this literature, maybe you should explain this a bit more. This explanation you gave, it's enough. So 1 or 2 sentences would be enough here.
Okay, thank you.
Okay, let's go in our first model now, page 12. Okay, why do we need constraints 4 and 11 together?
Just reading here.
Because they are quite similar, right?
4 and 11.
Yeah.
Basically.
What do we need both? And you can we replace them, for example, with a bound on your I variable, or there's a reason for that?
Yeah, so I can study it more and provide a better answer. So, but for now, I think we can implement this constraint 11 to include the explicit variable of I, of the idle sign of the job JK in the machine.
Okay, so you
Yeah.
mean there's no other way of getting this
not
value?
really.
Okay.
It's a linkage constraint also.
Okay. Well, it would be good to explain this also in the document here. Okay.
Yeah, good.
And maybe if you have some constraints that they are not needed, to guarantee a feasible solution, but they are there just to improve bounds or something like this, then you should mention that as well. Okay. I'm not saying this is the case here, but if you find something like this.
Okay.
Now, in constraint 16, I have another question for constraint 16. Next page. is V still this big value have the sufficient large value, the big M value?
Yes, it's the same value.
So I have a question. How is this an upper bound? Right? Because V can be as large as I can, as large as I choose this. So V can be infinite. Why is this an upper bound for Q?
Yeah.
If I can define, you know what I mean? You say you can define any value for V. You can define V as big as you want, 1 million.
Yes.
If this is true, how this is an upper bound? That's my question. Right? Is it supposed to be an upper bound indeed or a lower bound? Because then in the text you wrote this is a lower bound. And then if you look at if you look at the first sentence, inequality 16 are the lower bounds for the surpluses. And I said, well, they are either the upper or the lower bounds, right?
Okay.
So yeah, check this.
Okay.
Yeah, you don't have to give it, because sometimes it's just a typo or something like this. But double check this, because this is an interesting thing. And then if this is indeed this way, then explain why this imposes an upper bound or the lower bound. Because
thanks.
it lacks some explanation here just to understand this better. Okay.
Okay. Good question.
Okay. Good. In the experiment, in your numerical experiments at page 16, I like very much that you cited a paper regarding performance profiles that I didn't know, because I knew performance profiles when they just published this in 2002. I studied that, I'm using, and I didn't see anything else after that. And then this paper in 2016 by Gould and Scott, it's very interesting because they say of somehow I don't know, a drawback of this, right? You have to be careful using this. So this is a nice reference that I didn't know. So thank you. I like the way you present the results, so it was clear to me. The only thing I think, in page 18, when you mentioned that, well, I want to analyze if the model is effective and robust, right? The robust here, I think you should elaborate more on the definition of this robust. I know in the beginning you try to protect yourself saying, okay, I'm talking about robustness, but it's not related to robust optimization or anything like that. But anyway, when you talk about something is robust, for example, just counting the number of solutions, I'm not sure this would be a measure of robustness in this case. So my suggestion here is, okay, if you're going to use this word robust, so you should define how you measure this robustness in a more clear way. What do you mean this is robust? Right? For example, if you have a heuristic will be robust if you run different types of, I don't know, instances, and the gaps you get is never too far from the bounds you have. So if you run this with different types of instances, you do not get a very, very extremely bad case with this heuristic. So this is extreme. Or you never get a very bad computational time. Every time I run this heuristic, it gives me an answer in 5 seconds at most. So this is good. It will never be the case that I'll have to wait 1 hour. So regarding time, this heuristic is robust. And regarding the number of solutions, I do not see how to define this robustness, because either it provides a solution or not. And it's difficult. It's something like 0 or 1. It's kind of binary situation. You cannot say something like robustness to this. So elaborate more on this. That's my suggestion. Think about the way you use the word robustness here. Right? Okay. And there's something here at the end of page 18, because you're comparing the models, right? And then at some point you say, well, looking at figure 3 at this graph, you see that model 1 and model 2 are not good, right? But then this is exactly the case you have in that paper you cited regarding performance profiles, because performance profiles are good to compare, to say something about the best guy, right? So you can safely say that model 4 is the best one there. But the situation is, if you remove model 1 from your chart, from your plot, maybe the performance of the other models will change a bit. They will not be, maybe model 2 will be better than model 1. You don't know. This is the key, the main message of that paper you cited. I didn't know that, I learned, and I'm using against you now. Right? But yeah, just take care, just be careful with this, because with performance profiles, everything you analyze here is perfect, is fine. It's, first of all, it's not easy to understand this graph. So for again, for an undergrad student to understand this, it's a big achievement already. I have master students that, you know, they have trouble to understand this. And actually, it's more than understand, it's to analyze the results using this. And you did this very well. But then just take care of this, analyzing the models or the solvers that are below the best one. Okay. Everything there is good. Okay. Yeah. And then there's one thing more. I think it's my last comment about this. Table 7, you just show the results with your warm start procedures, with your warm start solutions. But then I could not identify if the solver itself, if the model is helping somehow to improve the solutions. It may be the case that you suggested, but well, this comment is based on the situation you provide the MIP start as a solution, but it works for the bound. Let's suppose you just provided the bound 100, the upper bound 100. Then you run the solver for 1 hour, and at the end, you still get 100. I mean, the solver did not find anything better than 100. You don't know that, right? So it would be good to see here in the results if when you run the solver for time, for the time limit here, it really improves something. It really improves the upper bound you provided. Because maybe if you see that for most cases here, or I don't know, 90% of the cases, you still get the solutions of you provided at the beginning while running the model. This may be a conclusion, right? So it should be something to state here, to be clear here. And okay, and there's, I said it was the last one on this section. There's one more. I missed a comparison here. So for example, you're saying that one of the main contributions of my work is that I'm considering this new objective function with idleness, with waiting times. Okay, but what if I solve the problem with the standard measures, with makespan? How your solution, how the solution we get will differ from these other solutions, right? You know what I mean? You have the classical way of solving the problems. Maybe you have even codes there that can provide you a very good solution. How does, what is the difference of that solutions to your solution? I mean, number of values. If you, of course, you take the solution you got with the other objective function, and then you compute the objective value with your objective function. Of course, for your problem, that feasible solution, is it good or is it bad for your problem, right? Just to measure how good or how bad would be the solution. This is one thing. And then the other thing would add to your document here is to have a toy example, just a small example that you say, okay, look how different will be the solution if I really use my objective function. Just to give some support to, you know, relevance of your work. Because I say, this is a new idea. Look, my contribution. I used a different objective function. Why is this important? Maybe I'm getting similar solutions to what I was getting before, to those I was getting before. Right? So that's my main point here. Just Would be nice to see this comparison. Okay. And the conclusions.
Thank you a lot.
Yeah, in the conclusions, I'm fine. Yeah. I just have one for the conclusions. I spotted something here. We were saying about warm start, right? Is this a common expression in this area? People use warm start when you impose an upper bound in the literature you looked, or something that you came up with this name? Because maybe you could use a MIP start, or because this is the name in the solver, or with an initial feasible solution, initial upper bound. Maybe warm start can be, I don't know, if we're from other areas, you can understand this differently. A warm start means you provide an initial solution and then you work on top of that solution, right? Or maybe you're using a branch and cut. Okay, I'll give you some kind of nodes already, and then you continue from that. So this is my suggestion here. Just look if warm start is really used in the same way you are using here in this literature. If so, you just can cite the paper and say, okay, I'm using warm start as defined by A, B, C, in the 2000s. If not, then find the correct way of saying this, stating this. Okay. Well, I think these are all my comments. As I said, it's just suggestions just to make this even better, just to help you with your paper, help you with this document. But the results you have so far, everything you've done so far is just great. It's just a way of improving even better this. Okay, thank you very much. Again, good luck with your next steps. Thank you.
Thank you for your comments. Thank you very much.
Excellent. It was a high-level evaluation according to the level of the researchers. Thank you very much. Precious contributions of both of you. Yeah, we are very happy. Aren't we, Alex? Okay.
Yes, you're really happy. Really happy.
Yeah, despite we are nervous. I'm nervous too, not only you, Alex.
Very nervous.
Yeah, that's another thing. Okay.
Okay.
So I ask to Alex and the audience excuses because we leave this room and enter in the other link to talk about the result, and then we come back. Okay.
Okay. We will be back.
Yeah.
Don't leave. Don't leave.
Wait us. See you. We came back.
Nice.
Fired. Anxious, Alex.
A lot.
Yeah. Yeah. Because it's Friday night in Spain, so
we need to hurry up this.
Yeah. And we are going to celebrate all together. Okay, so after thinking a lot, yeah, talking, we delivered, we decided that you are approved. So congratulations, but with a grade of 10.
Really nice, thank you.
Congratulations.
Congratulations. Thank you.
There was no discussion. It was the full proposal with no discussion at all. No questions asked. No need to discuss.
Yeah.
Thank you very much.
So the comments are interesting. For all the students attending, this is a top quality work. Okay, so if you want to be like Alex, you are kindly invited to do so.
Exactly.
Okay, congratulations, Alex.
Yeah,
congratulations.
Was Alex, if you are going to the master? So I answer, I hope so.
You better go.
The answer is definitely yes. Definitely yes.
Okay, yeah, very good.
Yeah,
Okay,
so it's
please.
Okay.
So Alex, would you like to say anything else to finish?
Yes, sure, sure. It's a huge honor. It's an absolutely huge honor. We are Helio and I we are developing a new paper. We are working a new project that Rubén Ruiz is the primary method that we are trying to adapt or trying to evaluate, and so it's a huge honor. It's a huge honor to have you all here and evaluate me, because as I said to Helio, I think that we need to aim high to have this great feedbacks as you gave us. So thanks a lot. Thanks a lot.
You're welcome. The honor is mine. And so far, so good. I think you're doing perfect. So aim high. Yeah, that's a good strategy. It's a perfect work. I will urge you to keep going in this line. I think you will get nice papers published if you continue this way. Yeah, very good.
Excellent. And also we need to thank Pedro, because Alex used your spreadsheet.
Oh, good.
Yeah, your
Great. It's
favorite
good to know.
spreadsheet of performance profiles.
Perfect. It's good to know that. It's still
So-
usable.
Very useful. And I think we could mention this in the paper.
Ah, yes, yes.
Sure. Yes, I write it down.
Yes.
Okay, good.
yes. And it was him idea to invite you, Pedro.
Okay, thank you. Well, I'm honored. Yeah, thank you.
Yeah. So thank you very much, Ruiz, both of you, and thank you, Alex, and thank you all of this big audience. I think it's not everybody anymore, but it was a big, huge
Yes.
audience that we thank, including Antonio, our technician. So, okay, we talk later, Alex, and that's it. Bye-bye. Finished.
Thank you, guys. Thank you.
Thanks a
Bye-bye.
lot,
Have a nice
Professor.
weekend.
Yeah, bye.
Bye-bye.
Thanks a lot.
Have a nice
Bye-bye.
weekend, everybody.
Bye-bye.
Bye bye.